Suppose the hypotheses are given to us as follows. The null hypothesis is that pi is equal to zero point 0.4. In context, it means 40% of people at a company walk to work. The alternative hypothesis is that pi is less than zero point 0.4, meaning that less than 40% of people at the company walk to work. Suppose we then collect a random sample of people at this company, and our sample has a statistic of p hat equals 12 out of 50, which is 24%. That means that we sampled 50 people, and 12 of those 50 walk to work. Finally, we use an applet to do 100 simulated repetitions, and we get the following result below. So part A asks, what is the value that this distribution is centered at? Now, I want to answer that question using the number of successes option and also the proportion of successes option. So I'm going to start with the proportion of successes option. Our null hypothesis is that pi equals 0 0.4, and your distribution of sample statistics will always be centered at the value from your null hypothesis, or with a simulated distribution, approximately that value. So with proportion of successes, our distribution will be centered at 0 0.4. What about if we were using number of successes? Since 40% of the 50 sampled people is 20, we expect that the distribution would be centered at 20. So under proportion of successes, it'll be centered at pi equals 0 0.4. And if number of successes is selected, it will be centered at 40% of 50, which is 20. Part B asks us to find the p-value using this displayed picture of the simulated distribution. A p-value is the probability of getting a sample statistic like ours or more extreme, assuming that the null hypothesis is true. Our sample statistic is p hat equals 12 out of 50, which is 0.24. The displayed distribution of sample statistics is displaying number of successes. So our number of successes is 12 successes out of 50. So on this distribution, 12 is located over here on the far left side. We want to find the number of statistics in this distribution that are like our statistic or lower. I say lower because our alternative hypothesis is that pi is less than 0 0.4. So we count the dots in the distribution that are like 12 or lower. That's these dots. There are 4 dots. There are 4 simulated sample statistics that are like our observed statistic or lower. So 4 dots out of 100, the p-value is 4 out of 100 or 0.04. Again, in summary, the p-value is found by counting all the sample statistics, the dots that are like our observed statistic or lower. Our observed statistic was 12 successes out of 50. So we need to count dots that are like 12 and lower. We do lower because the alternative hypothesis had a less than symbol. We counted 4 dots that were 12 or lower, so the p-value is 4 out of 100 total dots, which is 0.04. The p-value is 0.04, 4%. Next, we need to write a sentence to give the exact interpretation of the p-value. To do that, we use the definition of p-value, which is as follows. If we assume the null hypothesis is true, then the probability of getting a sample statistic like ours or more extreme is the p-value. Now we just need to take that definition statement and replace all the little pieces with the exact values and the context from this particular problem. So, if the null hypothesis is true, if we assume the null hypothesis is true, that is now replaced with this statement. If it's true that 40% of people at the company walk to work, because that was the null hypothesis, we assume that's true, then the probability of getting a sample statistic like ours or more extreme is now replaced with getting a sample statistic like p hat equals 24% or less is the p-value, which in our case is 4%. So overall, it reads, if it's true that 40% of people at the company walk to work, then the probability of getting a sample statistic like p hat equals 12 out of 50 people walking to work or less is 4%. And lastly, then, it asks, what conclusion do we make about these hypotheses? We want to know, do we support the null hypothesis that 40% of people at this company walk to work, or do we support that less than 40% of people walk to work? Remember, to make that decision, you need to understand the p-value in comparison to the significance level alpha. In our case, alpha is 0.05 and our p-value is 0.04. Our p-value is smaller than alpha. Therefore, we reject the null hypothesis and we support the alternative hypothesis. In summary, since the p-value is smaller than the significance level, we have statistically significant evidence in support of the alternative hypothesis. So in context, that means we conclude that we have statistically significant evidence that less than 40% of people at the company walk to work. So you just pick up your alternative hypothesis from up here. Less than 40% of people walk to work, and that's the statement that we support. So down here when I wrote it, we support this idea that less than 40% of people at the company walk to work.